Hello students, we'll now learn how to use completing the square method to actually solve quadratic equations. We can use this method even to convert the standard form of quadratic to the vertex form. So let's see how this goes. As a motivation, we'll start from multiplying two binomials. Because we know that factoring is opposite of multiplying, we'll first see how the multiplying goes for binomials. So when you multiply x plus 1 squared, so this is a square. It's just like saying 3 squared is 3 times 3, isn't it? Same way, x plus 1 squared is x plus 1 times x plus 1. So when you multiply, you'll get x times x is x squared, x times 1 is x, 1 times x is x, 1 times 1 is 1, right? This last square is 1, the product of the constants. Same way, if you see this, you can fill in this. So x squared, x plus 3 times x plus 3 is x squared times 3x. 3 times x is 3x. 3 times 3 is 9. So you know that last box is the product of this number squared, right? So you can easily guess that this time it is x minus 3. You can pause the video and guess this. Anyway, so overall, you'll get x squared plus 2x plus 1, isn't it? So here, if you actually go the backward way, this 2x is actually splitting into x and x. You see that? Now here it is 6x plus 9, right? The 6x has been split into half, 3x and 3x. And x squared minus 6x plus 9, which is the case here, the negative 6x is split into two parts, two halves actually, negative 3x and negative 3x. So that's the motivation behind this whole thing, right? So we'll move on. We'll now actually do the opposite. So we'll try to figure out what is this box, what is the value in that box, right? So this time, you are looking at the middle term, 8x. So you're splitting the 8x into 4x and 4x, two halves. And you're trying to guess what is in these. So x times x is x squared, which we know that. And x times what is 4x? X times what is 4x? X times 4 is 4x. And 4 times x is 4x. So 4 times 4 is 16. Okay, 4 times 4 is 16. It keeps changing, my bad. So let me just fix it a little bit. It keeps moving. Okay, so now in this case, now if you split 14x into two parts, two equal parts, this is what you get. So what would be the numbers here? You can pause the video and check it for yourself. And so here it will be 7 times 7 is 49, right? So you get the idea. So when you're actually writing this as a product of two binomials, it would be x plus 4 times x plus 4, which is x plus 4 squared, right? Remember this? We did this like 6 months ago. So here I would strongly recommend you to pause the video and do this question by yourself, okay? You can come back, right? So this would be a positive 25 and the binomial square is x minus 5 squared. All right, all good? Now, you can now guess, I'm trying to scroll this up. Okay, so now if you see, you could use the box method in your mind, visualize it, and write the values of the C and the factored form here. It's up to you, right? So C, you can even draw a small box here if you want. So when you split negative 14 into half, it would be negative 7 and negative 7. So negative 7 times negative 7 is positive 49. That's what will be here. And the factored form would be x minus 7 squared, right? So just go by, just if you are still not getting it, just pause the video or go back and see what I was explaining before. So now you can see here it will be Half of 12 is 6. So 6 times 6 or 6 squared is 36. And the factored form would be x plus 6 squared, right? All right, so on and so forth. So this is what happens, and we're using this technique that I listed above to actually bring this standard form into um, vertex form. We'll do the below ones first, because we'll do first with a coefficient of x squared as 1, which is the easiest one. All right, so here we have x squared plus 14x. You can do small mental math here quickly. Split the 14x into 2 halves, right? So you know that it will be a 7 here. So 7 times 7 is a 49. So we know that C is 49. So this is what we do. If you have to convert the standard form to vertex form, you would write this as x squared plus 14x and put a blank here, all right? And push this 5 aside. So what would go in this blank? 7 times 7, which is 49. So we just can't add a random number. We have to even subtract it as though it has never been. So we would subtract the 49 so that the 49 and negative 49 makes it a 0, right? But we are using this 49 to our convenience. So this whole thing, this trinomial, will now become a perfect square trinomial. Now this will be x plus 7 squared, and 5 minus 49 is a negative 44. So this is the vertex form, all right? And the vertex would be, since this is a naughty child, negative 7, negative 44, and so on and so forth. If you were to solve this to find x-intercepts, when you have to solve this, this is what you do, okay? So this is where it gets interesting. If you have to solve this, now x squared plus 14x plus 5, x squared plus 14x plus 5, you cannot do this by regular factoring method, x method factoring and so on that we have learned previously. So the best course of action is to push this 5 to the other side of the equation. So x squared plus 14x plus blank is equal to negative 5. So now we'll try to complete the square here. And we have just seen from this that here 49 will go into this blank. But since it's an equation, we have to add 49 on both sides, right? Because this is an equation. Earlier we subtracted it because it's on the same side. But here you have to add on both sides. That's the only thing. So x squared plus 14x plus 49. Now this would be x plus 7 squared as we did before, and 49 minus 5 is 44, right? So now we will apply square root on both sides because we want to remove the square. So this will be x plus 7 equals plus or minus square root of 44, because whenever we apply square root, we have to do plus or minus because there are two intercepts. And now subtract the 7 on both sides. X is equal to negative 7 plus or minus square root of 44. That's it. That's how you do it. So if you have a number in the front, what would you do? So this is what you do. Okay. I'll take this lighter blue. So anyway, into purple. So when you have a leading coefficient other than 1, here in this case it is a 5, right? So we don't like that. So what we would do is we would actually just take these first two terms, factor the 5 out first, just the first two terms, okay? And place a blank here and minus 13, okay? So that's what happens. And now by your box method or whatever, the C would be here, the C would be 1. But did we just add 1 here? If you actually see, I'm going to do this in a different color so you'll understand. If you actually see, if you distribute the 5 over all the terms, so this would be 5x squared plus 10x plus 5 minus 13, meaning we actually added 5. So when we add 5, we have to subtract that 5 in the end. That's what we need to do. Okay, so now we'll get back to the original color, purple. So now this would be 5 times x plus 1 square minus 18. So that's the vertex form. But what if it's an equation? You have to solve it. I'm using the same equation, my dears. I'm not doing these. These you do those for your practice. So 5x squared plus 10x minus 13 equals 0. Suppose it's a quadratic equation. So what would you do? You would actually first push this guy away as we did earlier. So 5x squared plus 10x equals 13. Since the leading coefficient is 5 and we want to get rid of it, divide the whole equation by 5. So that means 5 divided by 5 is just x squared, which is 1. And 10 divided by 5 is 2x equals 13 fifths. Okay. Now there should be something added here in this blank, which is a 1, right? So since we added 1, we have to add 1 on both sides. Please don't forget that. And now this whole thing will come to be x plus 1 squared equals, and do the fractions here, you'll get 18 fifths. Okay. Now you apply the square root, and this would be from here, this is the one from here. So here it would be just x plus 1 equals plus or minus square root of 18 fifths. And then subtract the 1, you'll get x as negative 1 plus or minus square root of 18 fifths. So that's the answer here. Okay, that's it. That's how you solve using the completing the square method. The same method is used to derive the formula for the quadratics, which is popularly known as the quadratic formula, where we sing the quadratic formula song and so on and so forth. You can avoid that formula by using this method, or use the formula itself. It's up to you. So this is it, my dears. I hope this helps. Thank you.